let's do another question, another problem related to this one. In this, what he is asking you, find the parametric equation and the symmetric equations of the line that passes through the point A and B. So what is the question here? So suppose that this is the line L and it is passing through these 2 points. The point A has the coordinates 2, 4, minus 3, and this point B has the coordinates 3, minus 1, 3, minus 1 and 1. So we want to find the parametric equations of this line. So as we know that in order to find the equation of a line, we need a point and the direction vector. So the first thing you need to do here in this question, that is, you need to find the direction vector. How can you find this direction vector? Since we are given 2 points and we can find the direction vector between the 2 points, we know that it is given by final minus the initial. So if you use that thing, you will get the following: 3 minus 2, that is final point minus the initial point, and then minus 1 minus 4, and then 1 minus, and here minus 3. And if you simplify this thing, you will get 1 minus 5, and minus minus here become plus. 1 plus 3 equals to 4, and this vector can also be written in the following way: I minus 5j plus 4k. So this is our direction vector. It means that the numbers which are written with I, j and k, that will be the values of a, b and c. Let's say with I we have the number 1, so that will be our a. B equals to minus 5 and c equals to 4. And now the other thing, we need a point. You can choose any one of these points as your x0, y0, z0. So let us choose that our point A, this is x0, y0 and z0. You can also choose the point B, there is no problem with that. Okay, so you can write it here. Let us choose x0, y0 and z0. This is the point through which the line is passing as the point A, which has the coordinates 2, 4, minus 3. 2, 4, minus 3. And now you can find, we have everything. You can find these parametric equations, okay, or the parametric form, and also you can find the symmetric form of the equation of a line, or you can just call it the symmetric equation. So what is the parametric equation? Again, I'm going to write these equations here. X equals x0 plus at, y equals y0 plus bt, and z equals z0 plus ct. Now substituting these values in these equations, we will get the parametric equations. So x0 equals to 2, a equals to 1. So then you will get the following: x equals to 2 plus t, and y equals 4 minus 5t, and z will be equal to this thing. So I will write them one more time. So x equals to 2 plus t, and y equals 4, and then here we have minus 5t, and z equals minus 3 plus 4t. And the next thing, you can find the equation of the symmetric equation of the line in the symmetric form, which is given by x minus x0, our a, y equals y minus y0 divided by b, and z minus z0 divided by c. Now if we substitute everything here in this formula, we will get the following, that is x minus 2 divided by 1, y minus 4 divided by minus 5, and z plus 3 divided by 4. So these are the parametric equations of the line. Now in the second part of the question, he is asking us the following, that is, at what point does this line intersect the xy plane? Okay, so remember one thing from your previous knowledge, I think from the first section, 12.1. In the 12.1, we know that this is, if you remember, if you recall this thing, this is our 3D space xyz, and this is the xy plane. This is the xy plane, and we know that in the xy plane, z equals to 0. Z equals to 0 in the xy plane. So put this value of z equals to 0 here, let's say in this equation of the z. Okay, so what you can do, put z equals to 0 where you want to put this z equals to 0 in this equation. That will give you minus 3 plus 4t equals to 0. And if you simplify this thing, we will get the value of t. So the value of t will be equal to 3 by 4. value of t equals to 3 by 4. Now substitute this value of t in these two equations, okay. So x will become the following: x equals to 2 plus 3 by 4, which is equal to 11 by 4, and y equals 4 minus 15 by 4. And if you simplify this thing, it will give you 1 by 4. So the point in the xy plane, so the required point will be equal to, it has the coordinates 11 by 4, 1 by 4, and 0. That's how you can find the equation of the line where it intersects the xy plane. Okay, before solving the next example, I will explain something to you. Suppose that we are in a 2D space. Suppose that we are in a 2D space. 2D space means we are in a XY plane. Here we have X, Y. So if we have any two lines, okay, so if we are given two lines in, you can say R2. R2 means the XY plane. Then there are two possibilities. Okay, there are two possibilities. That the first possibility is the following. That is, the two lines are parallel to each other. They are parallel to each other. So suppose that, let's say this is the line L1 and this is the line L2. They are parallel to each other. And the second possibility is the following, that if they are not parallel to each other, then the two lines are intersecting. Intersecting means they will intersect at some point. The two lines are intersecting each other. Two lines intersecting each other. So in 2D space, these are the only two possibilities. Either the lines are parallel to each other, or the lines will intersect at some point, at a point. Okay, this is called the points of intersection. But if we are in a 3D space, okay, now we are, remember, we are working in a 3D space, and in the 3D space we have three dimensions. Like here we have x, y, and z, x, y, and z. And now suppose that we are given, again we are given two lines. Okay, we are given two lines, but now here we are going to have three possibilities. Possibility number one, second possibility, and the third possibility. The first possibility is the following, that the two lines are parallel to each other. Parallel to each other. This is the first possibility. The two lines are parallel to each other. That is, let's say this is the line L1, this is the line L2. They are parallel to each other. The second possibility is the same as before in the 2D case, that the two lines intersect each other. They are intersect each other. The two lines intersect each other. That is, suppose that this is the line L1 and this is the line L2, and this is the point of intersection. But there is a third possibility, which is the third possibility. The third possibility is the following, that two lines neither parallel to each other. They neither parallel to each other. Okay, two lines neither parallel to each other and also nor intersect each other. Mean they are not parallel to each other, and also they do not intersect each other. So if we have this type of situation, mean the lines are not parallel to each other and also they are not intersecting, this type of the situation, then we call the line L1 and L2 are the skew lines. We call them the skew lines. So this is what we have to do in this example number 3. In this example number 3, he says we are given two lines L1 and L2. Show that the lines L1 and L2 with the parametric equations are skew lines. That is, they do not intersect and are not parallel to each other. Okay, and are not parallel to each other. So then you will say that these two lines are skew lines. Okay, so how can we do this thing? How can we show this thing? So first, in order to do this thing, that is, in order to show that two lines they are not parallel to each other, first of all you need to understand this thing. Okay, first of all you need to understand this thing. Suppose that this is a vector v1 and there is another vector v2 which is parallel to the vector v1. Okay, v1 is parallel to v2, is parallel to the vector v2. So if two vectors are parallel to each other, we can write them as a multiple of each other. that is v1 equals to t multiplied with v2. They should be parallel to each other. Now for the line L1, so what we are going to do here, from the line L1 and L2, we will write their direction vectors. And how can you find those direction vectors? You can find from the lines. These are the parametric equation of the lines given. The number which are given or written with the parameter t, that will give you the direction vector of the line L1, and the numbers which are written with this parameter s for this line L2, that will give you the direction vector for the line L2. So let's write them here. So from the line L1, we get this vector v1, and it has the coordinates 1 3 minus 1, 1 3 and minus 1. And from the line L2, we are going to get this direction vector. Its components are 2 1 and 4. Now suppose that L1 it is parallel to L2. So if they are parallel, if these two lines are parallel to each other, then these vectors should be the multiple of each other. That is, v1 should be a constant multiple of the vector v2. And if we substitute these numbers, the values of these vectors in this equation, we will get the following: 1 3 minus 1 equals t multiplied with substitute the values of the vector v2, 2 1 and 4. Now we know that you can multiply this t inside the vector 1 3 minus 1. It will give you 2t t and 4. Now 4t. So we know from our previous knowledge, if two vectors are equal, then their corresponding components should be equal. Okay, so what does it mean? It means that the first component of the vector v1 should be equal to the first component of this. So it will give you 1 equals to 2t. Similarly, this second component should be equal to this, that is 3 equals to t, and similarly this minus 1 will be equal to this, minus 1 equals to 4t. So from the first equation we will get t equals half, from here t equals to 3, and t equals to minus 1 by 4. So each of them are giving us the three different values of t. It means that v1 is not a multiple, v1 it is not a multiple of v2, and hence v1 is not parallel to v2. So we can conclude this thing, that is v1 is not parallel to v2. So we have shown here up to this point, that is L1 is not parallel to L2. Now the next thing we want to prove or disprove that two lines are intersecting or they are not intersecting. So how can we do this thing? So in order to do this thing, so what we are going to do here, now we want to check the following. That is, we want to check whether the two lines L1 and L2 are intersecting lines or not. So this is, we want to check now, are intersecting lines or not. So remember that if two lines L1 and L2 they intersect, it means that there will be a point which is common to both of these 2 points, two lines L1 and L2. Okay, so we can suppose this in the following way, that there must be a point which satisfies both of these two lines. So here we have, so suppose that here we have the line L1 and here we have the line L2. Let us write them. I will write them here. This is the line x equals to 1 plus t, y equals minus 2 plus 3t, and z equals 4 minus t. And the line L2, it is equal to x equals to 2s, y equals to 3 plus s, and z equals to minus 3 plus 4s. So it means that if at the point of intersection, both of these two lines will give us the same coordinate. Okay, at the point of intersection, both of them will give us the same coordinate or will give us the same point. So it means that the x component of the line L1 must be equal to the x component of the line L2, and similarly the y component of L1 will be equal to the y component of L2, and so on. So we can what we can do, we can compare them, or we can put them equal to each other. So when we compare them, that is when we put the x component from the line L1, that is 1 plus t, put this thing equal to the x component of the line L2, that is 2s. You can call this equation number 1. And similarly the y component, it will give you minus 2 plus 3t equals to 3 plus s, that you can call this equation number 2, and the z component will give you 4 minus t equals minus 3 plus 4s. That is our equation number 3. Now what we are going to do, we will solve any two of these equations. Okay, we will solve any two of these equations, and whatever the values of t and s we get by solving, let's say, equation number 1 and 2, those two values, if they satisfy the equation number 3, then we say that the two lines intersect each other. If they do not satisfy the equation number 3, then we will say that the two lines do not intersect, and hence we can conclude that the two lines are skew lines. So what we are going to do from here, so we are going to solve equation number 1 and equation number 2. So from equation number 1, you can find the value of from equation number 1, t equals 2s minus 1. Okay, and put this value of t in equation number 2. Put this value of t in equation number 2, and hence we will get the following: minus 2 plus 3 multiplied with t, it will give you here 6s minus 3 equals 3 plus s. You can bring this s to the other side, it will become 5s, and here you will get 8. It means that s equals to 8 by 5. S equals to 8 by 5, and put this as the value of s equals to 8 by 5 here in this the equation of the t, and then we will get 2 multiplied with 8 by 5 minus 1, and it will become 16 minus 5 by 5, which is equal to 11 by 5. So this is the value of t. This is the value of t, which is 11 by 5. Now we substitute these two values of s and t in equation number 3. Okay, what you have to do, put values of t and s in equation number 3 and simplify them. So and see what is our answer. So 4 minus 11 by 5, it is equal to minus 3 plus 4 multiplied with s, 4 multiplied with 8, it becomes 32 by 5. Now simplify this thing. On this side we get 20 minus 11 by 5, and here we get minus 15 plus 32 by 5, and if you simplify this thing, on the left hand side we get 9 by 5, and here we will get minus 17 by 5. Okay, I think 17 by 5, and we know that these two numbers are not equal to each other since they do not satisfy the equation number 3. So we can conclude that L1 is not, or do not intersect. Intersecting is not intersecting with the line L2. So these two lines L1 are neither parallel to each other, and also they do not intersect each other. So we can conclude that these two lines L1 and L2 are skew lines. So this type of the questions will come in the exam, where you have to prove or disprove that the lines L1 and L2 are skew lines, or they do not